Very good morning, students. I am Dr. Senthilkumar, Associate Professor in the Department of Agriculture Engineering, SNS College of Technology. And now we are going to discuss about the case study 2, that is a fridge in space, a case study in thermodynamics. This is mainly applicable for the second year students of agriculture engineering as well as the second year students of food technology in our college, and we have gone through the basics as well as the first law of thermodynamics, second law of thermodynamics, etc. Enthalpy, entropy, where and all application either in a closed system or in case of open system we got discussed in our normal class. Now we will discuss about a fridge in space. That means where if you are placing our fridge in a case of a space, what will happen? It is a case study that now we are going to discuss now. And to say about the case overview and the background, this past spring, a team of 3 juniors working on the senior year project faced the situation described in the case. They were enrolled in a independently study in preparation for a on-site research project. They were to conduct a cryogenic group. To save the cryogenic group, when it is in minus, that is in case of minus 15, minus 20 degrees Celsius, we used to term it as the cryogenic case. So cryogenic group of Dr. Peter or the NASA Graduate Space Flight Centers in Maryland. So they came to find out there's such a problem. They came to across like these things. 2 out of the 3 had not taken any course in thermal physics. That is a main thing. So most of the students, they are interested in studying, but they are getting afraid from doing this course. So this case would be appropriate to students enrolled in thermal physics course, not only in case of thermal physics but also in case of people or the students who is carrying out the course of engineering thermodynamics. This also will also helpful for the thing. Now to say about a heat engine is often described as a black box labeled with 3 parameters, that is heat in, heat out, also the work done. That means we know very well about the first law of thermodynamics. To say about the first law of thermodynamics, the heat that is given to a system, either it may be a closed system or open system, whatever it may be, when the heat that is given to the key system, what is happening? To say about the process that is happening, for the heat that is given to the system, the given heat is being converted to useful work, and remaining amount of work is converted into internal energy, storage of internal energy. So in all the cases, in whatever may be the system of thermodynamic system, we used to consider only 3 cases, that is heat in, heat out, as well as the work done of the system. So develop critical thinking and reasoning skill. The students is constantly asked to analyze the statements. Some of the statements are given to the students and they are asked to analyze what is going on, what are the things that they want to study, etc. So train students to synthesize facts from various portions of a course. This problem involves a wide variety of thermodynamic principles. If we are strong with the principles of thermodynamics, then it will be easy for us to go through this. So then to say illustrate a variety of physical parameters, we often solve problems with normal parameters. Example at room temperature, that means in case of normal temperature, room temperature, not in the atmospheric pressure, we used to solve most of the problems, but in actual, in case of industry, it is not the case. So we want to think about the other things. That means we want to vary the temperature, we want to vary the pressure, etc. Then to say, while we also discussed that is the low temperature specific heat capacity often as the indication of failure of classical models. So classical models we used to say in case of normal temperature. So failure of classical models, that means in case of we are going for a cryogenic, that means the temperature range is minus 15, minus 20 degrees Celsius to minus 30 or up to minus 100 degrees Celsius. We used to term it as cryogenics. It is never stated that the low temperature value itself has a practical applications. There are many applications. That means even in case of food processing or in case of other, either it may be a cool and wherever it may be, we are using this cryogenic as an important application. So we want to illustrate the difference between the textbooks and the real life physics. For example, the textbook definition of efficiency of heat engine is not what is important to the NASA scientist here. That means actually as of practical, it is surely it is getting varied. what you have studied in our class is quite difficult from what is there in the actual application. Next to say about the analysis of major issues. To say about the major issues, the second law of thermodynamics, both the Kelvin and Clausius statement is to be discussed, is to be known very well. Then the abstract textbook heat engine is misleading. That means the textbook itself, what is given is misleading the students. The application of work done does not automatically and directly allow heat transfer from a cooler to a hotter body. That means when a body is in cool condition, we can't say automatically it is moving from the cool body to hot body. Another point which is not illustrated by the abstract heat engine is that the fact that is operation is influenced by the capacity of the stored heat energy. That means whatever is amount of heat energy that is stored, that is mainly influencing over the calculation of work done is of interesting one. Students typically learn that for a PV diagram, that is pressure volume diagram, the work done is dW equal to PdV, while for a magnetic system the work done on a magnetic material is dW equal to minus, the formula is given over there. We can also do various things. However, the efficiency of energy is defined. The textbook fridge has a efficiency which is defined as the heat extracted divided by the work done. That means what is the amount of heat extracted by the system divided by the work done by the system, that we can say. For the ADR, the NASA scientists are more interested in the ratio of the heat clumped at high temperature to the heat extracted to low temperature, that is being considered. The magnocaloric effect is a standard topic. Hopeful this example will be helpful students to understand it will be more better. Next to say about the references. These are the various papers that I have taken for the reference of this case study. That means usage of fridge in case of space, and while we are using the fridge in case of space, those things that is major issues. What are the major issues that we have to consider? What are the things that is involved in case of usage of fridge in case of a space is to be considered. Then we should have the case objective. What are the things, what are the main things we want to understand? That is the second law of thermodynamics, as the Clausius law of both the things are important. Next to say about the acknowledgement. This case was developed as a part of National Science Foundation sponsored case studies in science workshop that is held at State University of New York at the particular place Buffalo University on June 7 to 11 1999, and is based on the work supported through NSF Career Award, that is NSF grant number is given. The author is grateful to Dr. Sriram for his permission to use his ADR project on the basis for this case. This case study is actually derived from his work. So I actually acknowledge, I thank him for approving to propose this work. The author would also like to acknowledge and thank the American Institute of Physics for permission to reproduce the cover of August 1999 issue of the Physics Today. That means this author is using the cover of Physics Today issues, that is the issue of August 1999 issue for the publication of using over here. Thank you everybody. Thank you to all my students for listening to this case study patiently. Thank you.